Hey folks, just want to do a quick video and give you some examples of solenoids. Now you should have watched the video already that I have up here about how a solenoid works. You know that it's a coil and makes something move. But what things do we use that for? That's what I want to talk to you about. Is like where would you find them in everyday life? Um, First of all, one of the main places we would find solenoids would be when we're in regular school and you come in, let's say you come into school late and the front doors are locked because of security, and you come up and you push the button and say, hey, can I get in? And they look at you in the camera and say, yeah, you can come in. And you hear a click on the door, and then the door's unlocked and you can open it. So um, there are a lot of, let me get back to my whiteboard. There are a lot of um, oh, I gotta come down here. There, there are a lot of different door locks that use solenoids, and basically all it is there's inside the door there is a coil like this, and there's a bar inside of it that locks, and there's a spring on it so that in the normal time when there's no electricity applied to it, this bar is in the main door sash or whatever of the door, so you can't get in. When somebody pushes, and it might be the opposite way around. This portion might be um, in the sash, and then this just sticks into the door too. It can be either way. But at some point, somebody applies electricity to it. This mechanism moves that way because of the electromagnetic force, and moves it back to say here. Now you're free to swing the door open. That's all that's happening. Okay, it's real simple. Um, Great tool though. We use it all the time. Where's another one? If you look in your car, on your car, um, on your starter of your car, we all use this. On your car, there's a big ring gear, and on your starter, there's a little gear that each of these has teeth. This is a really poor drawing. And this little gear is connected to an electric motor, and that's what gets your car started. So this thing, the little gear starts turning and turns that electric motor, boom, 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 gets it going, gets it started going. But you don't want this portion of the car. Um, you don't want this to be engaged to that all the time. You would just destroy this thing because it'd be running all the time, over and over and over again. So what happens is that this shaft has a solenoid in it that when you uh, do the starter, if your starter goes out, you can actually usually hear this. You'll hear a click, and the click is as electricity is applied. This little gear moves into connection with that. When that is released, that moves back. Okay, so it makes the gears either engage or disengage, and that's what starts it. So you go, okay, I want to start it. Here's the big wheel. Here's my little gear. You turn the car over to start, and the little wheel goes chink over. Then it starts turning it. As soon as you're done, you release the key so it stops trying to start. It moves back, and then this can spin freely. Okay, that's how the starter works. So the other way, another way that we use this quite often, lots and lots of these around, um, is we use these as um, here we go, electrical switches. So let's say we have a big electrical current here and a big electrical current here. So we want to make this connection right here. I'll give you some examples of when you would do this. You want to make this connection so that you're going to use a switch here. But there's two things. First of all, you don't want to be near that switch because there's a lot of electricity there. And number two, you don't want that switch to be the switch that you throw. You don't want to have to be a big, huge switch of some kind. You want it to be something small. So what you might do is this. You might have a coil here, and I'm not gonna do this very well, but you might have something here that when you put electricity to it, it makes the connection. So let's say that like in the video that you showed, that he showed how that nail moved through there. Let's say there's electrical connectors on each side, and then that nail, when he puts that electricity through that coil, the nail goes, and that nail creates that conductivity. So something creates that conductivity there by using that. And this coil, let's say, goes to some small electrical thing, like maybe a battery or maybe a small little switch up here that we use to do it. Now, what are some examples of this? On your car, again, there's a solenoid, not your starter, not the solenoid that puts the starter gear up, but you want the electricity to be able to go through all of the parts of the car. But if all of your electricity, think about the size of your battery cables, if all of that electricity had to go through the switch on your dash, if you have a car still that has one of those switches, you'd have to have a huge switch on your dash. But instead, you have a little bitty switch that has little bitty wires to it that goes to a solenoid like this, and then that solenoid makes the connection between the two big wires and lets the electricity flow through the car. Otherwise, you'd have to have that solenoid side switch in the dash of your car. Okay, so that's one thing, and the other thing is you'd have to deal with switching a big switch like that. But instead, we can use electricity to do it. We also do that when we are using like bigger electrical things. Like let's say I can remember I had a place that had lots of lights, great big outdoor lights, like all of the parking lot lights. Okay, so there's a lot of electricity in there. So we have big wire and big electrical load going to all these lights, but we had them turn off and on by a sensor that sensed light. And when that sensor sensed that the light wasn't there anymore, then it would release. Actually, in this case, it released, so no electricity was here, so it sprang back the spring so that it made the connection. So it was kind of a backwards wired deal. So that when it was dark, that connection was made, and the electricity flowed to all the lights. If I didn't have that solenoid in there doing that, then all of that electricity would have had to flow through that little bitty device, and it would have burned it out. In fact, I had an electrician at one time try to do that, and it burned it out. And I called somebody else who was a little more knowledgeable, and they were like, "Well, you can't run all that stuff through there. There's just it isn't made to handle that kind of power. It's made to handle just a little tiny bit of power, just enough to power that solenoid, so that switch can throw the bigger power and do things." So that's how we kind of use it to automate things and control things in that way. So there's just a few examples of how we use solenoids. We use them all the time in all kinds of things. We use them. I used to use them in industry for valves. That when you threw that little plunger, it would control a valve that controlled water or some other kind of chemical that would have a just like you turn the valve on your faucet at home. The plunger would either open it or close it, and would let things through. We use it for many different things. There's a solenoid valve on the Usually on the fuel for your vehicles, there'll be a little valve in there that turns the fuel off and on, all kinds of things like that. So, anyways, just areas where it's easier to use electricity to throw a switch than it is for us to throw a switch. That's usually where we use a solenoid. Okay? So, thank you and have a great day.